Alright, box whisker diagrams then. Hopefully you're all alright at drawing them, but you've got to also analyse them for these questions. You've got to sort of say something about your results. You've got to remember what a box and whisker diagram is showing. You've got the maximum and minimum at the end of the whiskers. You've got the median as the line in the middle of the box, and then the ends of the box in the middle are the interquartile ranges. So that means that the 25% of the data is lying between the first line and the first line of the box. The next 25 is from the first line of the box to the median line, and from the median to the end of the box, the next 25%, and then the final 25% is from the end of the box to the end of the whisker. So, an obvious thing to start with is to compare the medians. Is the median of one higher than the median of another? If it is, that means that the midpoint of the data is higher, so that's often a good starting point for comparison. So if these are like class marks, you could say the median of group A, the top one, is higher than the median of group B. The other thing to look for is how spread out it is. So you could say of the top one that although the median is higher and was 49 as opposed to 39, the range of the group was much wider, with the top performer scoring 95 and the bottom performer scoring 2. So there's a much greater range of ability in Group A as opposed to Group B. So that consistency or reliability, or that's something they often look for. It's sometimes acceptable to have a lower median if you're more consistent. So, for example, or you can argue the case either way. It doesn't really matter, but it's a point to make. So I'll just draw for a bit and then I'll talk again. Hang on. Okay, so if you get something like the thing underneath, so let's say that the scale this time is showing meters thrown in a javelin competition. The competitor A, the one with the smaller range, is much more consistent throwing. All his throws are between sort of 42 meters and 72 meters, and his median's 51. The second one has had throws of like 90 odd, but he's also had throws of 2. So you can argue either way. You can say, well, look, we should pick the second one because his maximum is much higher than the first competitor, and so therefore he could pull off an amazing throw at the competition. Or you could also say he's very unreliable. He sometimes is amazing and he's sometimes terrible. So do we want someone like that in the team? And that could be a question about the reliability of spare parts in a car, for example. You might rather have something that lasted consistently between 42,000 and 72,000 kilometers, as opposed to having a part that failed after 2 kilometers or 2,000 kilometers, but sometimes made it up to 95,000 kilometers. So it depends on the context of the question what is better or not. But the wider the spread, the less reliable it is, or the less consistent it is, and the closer together they are, the more consistent they are. The other thing to note is that a maximum could be a one-off thing. So, for example, again, I'll be quiet and draw again. Hang on. Okay, I went a bit mad with the whisker on the last one, but if you had something like that, what that's showing is that 75% of the throws, results, length of time that the thing lasted was below 40 on the scale. So 75% of the things fell before 40 meters, or lasted less than 40,000 kilometers, or scored less than 40 on a test. 25% were between 40 and 100, But that's not to say that they're evenly spread along that scale necessarily. They might be, but we don't know. We just know that the top 25% starts at 40 and ends up at 100. Now that could mean that 24.9% of that top 25% was between 40 and 50, and for some reason there was a very strong wind that day that happened to carry the javelin 100 meters, or there was just this fluke spare part that did last 100,000 kilometers. So that the top 25 and the bottom 25% on these diagrams are very susceptible to just one result, which is why, for example, we talk about the interquartile range more than the range, because that middle 50%, if you think about your normal distribution curve, the middle 50% is the majority of people, of heights, of weights of marrows, all that sort of stuff. It all tends to cluster around the median, around the mean, and then then after that it starts getting to the outliers, and you get the odd freak results, and you get some massively tall people, massively heavy marrows, massively like maybe they got naught because they tripped over and the javelin just hit the ground in front of them, and that was one time, and you've just got to be aware that one result could make those whiskers very, very large. So it's like, for example, on the bottom of these three, they look pretty rubbish, really. 75% of them are are right at the bottom, and the top 25%, I can't guarantee that they're getting anywhere near 100 most of the time. So the middle bit's probably more important, which is why it's a box than the whiskers. So compare the medians. Talk about how the each 25%, each quarter is distributed, and compare those. Talk about the the more spread out they are, the more reliable they are, less reliable they are, and what else? I think that's about everything I think of. But there's one or two comments. It doesn't have to be a major essay. Just it often asks for a certain number. Does it say? Okay, so in this case, which group is better? Justify your answer. Well, okay, I don't know, maybe the median's a bit higher, one's more reliable than the other. The bottom 25% is particularly poor on Team A as opposed to Team B, or the top 25% seems to be better on Team B than Team A. Those sort of things, just discuss those, and that's probably enough for the question. It's not going to be, it's only 4 points, so you don't have to write a massive essay. Okay.